Hi everyone, our semester project is called Vizualizr. It's a real-time image manipulation software based on audio. The project is completed by Andy Boffman, Roger Link, and Stephen Campbell. So our inspiration for this project was to develop an application that will allow musicians to enhance their live performance with dynamic digital imagery, which can help the musicians create a more immersive environment during their performance. The application will allow these musicians to provide their own imagery while also supplying supporting imagery directly from the application. And the imagery will be manipulated based on characteristics of the audio that is supplied. So our application focuses on two main areas that we covered in this course. One is image evaluation and manipulation, and the other is audio signal processing. Our application will evaluate an audio input in real time to build an array of data in which to base a series of image manipulations off. The data array will be based off of frequency and pitch of the audio, and the audio can be either an MP3 file or a direct stream from the user's computer, microphone, or like a USB microphone. So as the audio progresses, the application will make image manipulation decisions based on the information within the audio data array that is being built. Our application uses the Web Audio API for audio analysis, and the Web Audio API is a high-level JavaScript API for processing and synthesizing audio in web applications. So the main methods within the API that we are using involve time and frequency-based analysis. And our application evaluates the pitch of the provided audio using a zero crossing point detection. So the audio stream is being sampled continuously from the supplied audio file or microphone in 1 kilobyte samples. As the audio sample window is analyzed, frequency ranges are recorded, retrieved from the fast Fourier transform data in a method called createAnalyzer within the Web Audio API. The application stores the window of signal data between one 0 point and the next consecutive positive 0 point, just focusing on that positive value range. And we use the frequency data within that range to compute the pitch. So in computing the pitch, the sum of the data between the two zero crossing points is divided by the number of samples within that area, and then the sample rate of the audio input is divided by the sum to produce the pitch. And this sample rate from the Web Audio API is a measure of the linear pulse code modulation within the audio buffer. For the image manipulation, they are altered by a process that reacts to and is an abstract graphic representation of the characteristics of the audio stream. The frequencies and the pitch of the audio stream will control the pace and behavior of the image manipulation. There are two main types of images within the application, one being user supplied. At this point, users would need to place image files within a specific folder in the application file structure, although future improvements that we would like to make to the application include more of a web drag and drop interface. It would be a lot more user friendly. And if the images don't match the required dimensions or size, we will be implementing OpenCV's CV resize function. So in the demo I'm going to show in a moment, we will be using two user-supplied images, and here are what those look like before they are manipulated. And then the second type of image is a geometric composition, which we will use OpenCV's find contours to find open areas within this geometric composition to be used within the manipulation process. And the complexity of the composition is based off of the complexity of the frequency range within the audio. So here is the sample composition that we will be using in the demo. So these open areas would be picked up by OpenCV, and it'll be pretty clear how those are used when you see the demo. So during the analysis, one user-supplied image is kind of transformed into another. Technically, those would be chosen alphabetically by file name, just so they have a set order in which they are chosen. And as I mentioned before, we'll be using the find contours function to find those areas to use. And then the transformations themselves are being performed using the canvas element within HTML5. The rate in which the imagery will change is determined by the pitch. Each time we detect a new pitch, new in reference to the current, then we will manipulate the image. So if the current pitch within within a specific moment is C, and then it changes to D, well, then the image will be manipulated. If it remains C for a period of time, then the image will remain as is. The colors are also updated within the image with varying layers of opacity, and the color choice is made based on the frequency value. So the intended use of this application is for a musician or a band, a group of musicians. So in this diagram, you would see that, say that the musicians are on a stage. Further back, we've got kind of a laptop set up, and then this projector that is at a height that would not interfere with the musicians themselves, and then it's projected onto some type of backdrop behind them as they play. So the minimum equipment requirements that we had thought would be nice. It's either some type of computer with access to a microphone, a projector to project the imagery behind the musicians, and then a screen or a backdrop in which the projection can be displayed. And ideally, a PA system would feed audio into the computer. It would be a lot higher quality than just a microphone, but it's not always available. So in this demo, you'll see the user-supplied and geometric images that we have looked at in the previous slides, and then the demo is just using an MP3 as the audio source, not a live input. Too long, but you get the general idea. So we used Python mainly because it's easily web-based, and we could use OpenCV with it. We used a web framework just for a model view controller type of architecture, and then we also used Google Chrome, which supports everything HTML5, the web audio API, canvas element. I've already mentioned a few of the future improvements, although some of this goes into a little more detail. With the user interface, as you saw in that demo, it's very basic. I just click a button and it goes. I didn't walk through any of the audio upload or image upload process that we envision, but we would like to stream that and make it a little more user-friendly and sophisticated. Right now, the live audio input isn't quite as reliable as we would like it to be, so that's another area that we would like to improve. We would like to allow users to upload their own geometric imagery that would correspond best to the photos that they chose. If they choose to just use the system's geometric imagery, that's fine as well. We also thought it would be nice if users could drag and drop images into the canvas area as the audio is playing to have more of a dynamic image manipulation process. And then right now the colors being used are based off of frequency ranges, although we thought it would be nice to choose colors from kind of the second image in the process. So say that one image is displayed, we've got the second one kind of waiting and being entered into the canvas as the pitch changes. So we thought it'd be nice to pick up colors from that second image, the one that's being placed on top of the first, to have the overall composition be a little more cohesive. Thanks everyone. Thank you for taking the time to watch our presentation. We had a great time during the class, and have a great summer. The audio in the demo can be found in the Free Music Archive following this link. That's it. Thanks.